Here's the solution to one of the problems from the Chapter 5 review, the integration review. This is one that mentions left and right Riemann sums. The problem starts with a table of data that tells you time of day versus a rate of production of, what are we producing? Bagels? All right, sure, why not? Bagels. And so we want to estimate the actual number of bagels produced using left and right hand Riemann sums. Now, the first thing we have to do is make these units the same. Notice on the left-hand side, the time is given as the clock time, but on the right, the production rates are given in bagels per minute. We need those time units to match. So I'm going to just change the times to be in terms of minutes. So we'll have 0 minutes, then we have 15 minutes, then we have 30 minutes, 45, 60, 75, and 90. So this all is happening over a 90-minute period of time. Now because we have the units matching, when we multiply minutes times bagels per minute, then the result of that will be an answer that's in terms of bagels, which is what we're trying to count. Okay, so we're given 7 values, which cuts the interval from 0 to 90 into 6 sections. So we have 1, 2, 3, 4, 5, 6 subintervals. So to form a left-hand sum, over each of those 6 subintervals, I'm going to draw a rectangle. And what makes it a left sum is that the top of the rectangle is going to touch the curve at the left-hand side. And so over and down, not so good, over and down. My rectangle touches the curve on its left-hand side. The top of the rectangle always has to touch the curve with the Riemann sum. It's just a matter of where it touches. So my next rectangle, height of the curve is determined by the left-hand side. Notice it touches the curve twice, but the height of the rectangle is determined by where it touches the curve on the left. Height of the curve comes from the left point on the top. Height of the curve comes from the left point, and so on. So the sum of these 6 rectangles is going to be my estimate for the total number of bagels produced. Each of those rectangles has an area that's just base times height. The base of every one of them is 15 minutes, and the height is determined by the y-coordinate where it touches the curve. If I back this up, go back to my graph, the right-hand Riemann sum, the right-hand Riemann sum is going to come from drawing rectangles. Again, every base is 15 minutes wide, but now the height is determined by where the top right-hand corner of the rectangle touches the curve. So this is my first rectangle, my second rectangle, top right corner of the rectangle is touching the curve. Every time I'm drawing a rectangle, the height is determined by where the top touches the right-hand side of the curve, where the right-hand side of the rectangle touches the curve. So again, I'll have R1, R2, R3, and so on. And again, we're finding the area of these rectangles each time. And I sum those together, and that is my right Riemann sum. If you draw a careful picture, unlike my scribbles, your pictures will look like that. Here's the, we would write L6 for the left-hand Riemann sum using 6 rectangles, and this would be R6. I did not work out what the answer was, but I think the problem is randomized, so it wouldn't help anyway if I did. But the calculation here will be something like the width of the first rectangle times the height. Height of the first one is 45, plus width of the second rectangle times the height of the second rectangle. Here the height of the second one's easy to see. It's 80. I should be getting these from the table, but I can't see the problem and the picture at the same time. So this one has, oops, let me not write it that way. I can't really fit that in there. So 15 times 45 is the area of this rectangle. 15 times 80 is the area of this rectangle. The area of this one is 15 times 75. And so on. So I'll have 6 numbers added together. The 6 right-hand rectangles, again, the bases are all 15. The first rectangle has a height of 80. That's this point right here. The second rectangle has a height of 75. And so on, until I've added together the areas of all 6 of these. You can see that from the picture that this estimate probably is a little bit high. I've got a lot of rectangles sticking up above and only one below. Here, probably a little low, but they're both going to be pretty close. In both cases, there's some places where the rectangles are too big and some places where they're too small. So between the two of those, you'll get a pretty good estimate of the total number of bagels produced over the 90-minute period.